Continuing with the power system stability, can we seen that in the last session that if there is an imbalance occurs in the system, then it is prone to instability if there is no sufficient restoring forces. Then, what are the disturbances in the power system which makes the system unbalanced? That we'll see first. That is, a disturbance in a power system is a sudden change or sequence of changes in one or more parameters of the system or in one or more the operating quantities. That is, if there is an imbalance occurs, if there is any change occurs or sequence of changes they are occurring in the power system, that is nothing but it is affecting the changing the operating quantities, that is voltage, load angle delta, frequency, active power, reactive power. That what we are calling is the disturbance. That is the disturbance which is causing the imbalance. Then these disturbances can be categorized into small disturbances and the large disturbances. The small disturbances means it is a disturbance for which the equation that describe the dynamics of the power system may be linearized. That is, the change in the system parameters because of the fault is very small, very small. In that case, you have to the dynamics of the machines or dynamics of the power system can easily related with a linear equation for the accurate analysis. Whereas in the case of large disturbances where the dynamics of the power system cannot be linearized, the purpose of accurate analysis means the disturbance is very large and the equation governing the input output relations is a not a linear equation, it is a non-linear equation. Then once again we will review the overview by the power system stability. Then what are the two important stability studies you are studying in our the curriculum? Once again I am defining here the power system stability. It is the ability of the power system for any given initial operating condition to regain the state of equilibrium once again in the event of any disturbance, with the most of the variable bounded so that practically the entire system remains intact. That is, in the event of any the fault or imbalances they are occurring, in that case, if the system is regaining its original state of equilibrium portion, then it is called as the power system stability. The power system stability can be classified into mainly the three categories actually: the steady state stability, transient stability, and dynamic stability. But we'll concentrate on right now on steady state stability and a transient stability. In the steady state stability, the power system has a steady state stability for a particular steady state operating condition. If following any small disturbances, it reaches a steady state operating condition which is identical or close to the pre-disturbed operating condition. This is also known as small disturbance stability studies of the power system. It does not be called dynamic stability. Okay, that is, in the event of any small changes they are occurring, the system is operating under steady condition. The steady condition means there is a perfect balance between the input, output, and the losses. Now there is a small disturbance occurs in the power system. In the event of the small disturbances, once again the system is regaining the balance between the input and the output and the losses, then it is called as a steady state stability. It is a steady state studies are concerned with when there is very small changes they are occurring in the system. But these are not called as what he is telling is a dynamic stability. Means in the dynamic stabilities also the disturbances are very small, but they are lasting for a longer time. Therefore, that what we are calling is dynamic stability. Okay, the steady state stability is the disturbance is very small, lasting for a very small time. Immediately by a corrective basis in the system, and the system is regaining its once again steady condition. Whereas in the transient stability, the power system is transiently stable for a particular steady state operating condition and for a particular disturbance. If the following that disturbance, it reaches an acceptable steady state operating condition, that what we are calling is transient stability. That is, the system is before any disturbance occurs. The system is operating at steady state condition. Steady state condition. Now there is a disturbance occurs on the power system. Now what is the nature of the power system, disturbance? A very large disturbance occurs in the system. Therefore, that study is fall under a transient stability. When the system is operating at a steady state condition, very large disturbance occurs in the power system. In spite of that large disturbance, once again the system is regaining its original or a next steady state condition or nearer to what he is telling, reaches an acceptable steady state operating condition, then the system is called as transiently stable. And this type of study is what you are come under a transient stability. Once again, I am defining the power system stability based on what I defined so far. That is, the power system stability is the ability of an electrical power system for a given initial operating condition. Initial operating condition means before any disturbance occurs, the system is operating at a steady state condition. That is the balance condition. To regain a state of operating equilibrium after being subjected to a physical disturbance with most of the system variables bounded so that practically the entire system remains intact. That is, when it is operating under steady state condition, any disturbance occurs, the system is regaining its steady state conditions once again. In that case, all the system variables bounded in a particular limits, they are operating under their limits, so that practically the whole entire power system remains in the stable condition or remain intact. Then the step by step of the evaluation of the stability studies are stability of the power system. We are already defined this as its ability to return to normal or stable operating condition after having been subjected to some form of disturbance. Then conversely, instability. Stability is it is regaining its original steady state condition. Conversely, instability means it is condition denoting that loss of synchronism or falling out of step. That is the restoring forces are not sufficient to counterbalance the disturbances. In that case, the system is going into the unstable condition, or it is also going, it is a loss of a synchronism or falling out of step. Though stability of the power system is single phenomenon for the purpose of analysis, it is classified as steady state analysis and transient. Just now we have seen that is a stability studies is only one phenomenon, but depending upon the nature of the fault or nature of the severity of the disturbances, you are classified into steady state analysis and transient stability analysis. That is, what do you mean by disturbance? It is given very simple way. Increase in a load is a kind of disturbance. If increase in loading takes place gradually and in a small steps, and the system withstand this change and performs satisfactorily, then the system is said to be steady state stability. In a very simple manner, it is defined here. That is, there is an increase in the load. There is an increase in the first, the system is operating under steady state condition, making perfect balance between the input, output, and the losses. Now, thereafterwards, there is a small increase in the load. Steadily, there is a small increase in the load. However, in spite of increasing the load, then system is regaining its the stable condition by increasing the generation, making the balance between the generation and the demand. Then the system is remains the stable condition. Such type of the stability studies are called as steady state stability. That is, here there is a gradual change in the load. There is a gradual change in the load. When there is a gradual change in the load and system is regaining its or steady state condition, then the system is called as the steady state stability. Thus, the study of the steady state stability is basically concerned with determination of upper limit of machine's loading before losing synchronism. That is, if you are go on increasing because the generator is having a particular capacity, then it is not fully loaded, then there is a gradually increase in the load on the system, and the generator goes on delivering the whatever is the required power, but there is a limit for that. The generators have got their maximum capacity. Beyond that, if it is increased the load, it is losing its synchronism. Then what you have to define is here is the upper limit of machine's loading. Beyond that, the system is losing its stability. Therefore, in the steady state stability analysis, our main aim is to fix the upper limit of machine's loading. Then you can see the very simple diagram here, and how exactly there is a change in the system parameters in the event of imbalance between the generation and the demand. That is, if you look into the balance here, if there is a generation and loads they are balancing each other, the balance is perfectly the balancing between load and generation. Suppose the loads are increased, the load is increasing, then what you have to do here, generation, you go on increasing the generation. If the capacity is going beyond the demand what it is required here, in that case you have to start with operating reserves for a contingency events, because very large sudden change in the load is put on the system. In that case, the more energy is required. In that case, the generator is not capable of handling that situation. In that case, there is an operating reserve for the contingency events. In other words, means when the load increases, if the generator capacity is over, then it has to import the power. That is, some or other, either there is a networking or a grid connection, so you have to draw and you have to pump the power there. That is what we are calling is generator and imports. Loads and exports. Exports means when there is a large, the loads they are come on that one, then there is a large generation is required, or the total generation should be balanced with this load. Suppose some of the loads are disconnected. In that case, the load is less, generation is more. In that case, that is, whatever there is a loss of load here, and in the excess, the generation is balanced here, that can be the exported. That is export. That is the meaning of there is a balancing between the demand and supply is very essential. Okay, you have to make a proper balance between demand and the supply. Okay, in the next session we will see the what do you mean by the transient stability.